Charging by induction occurs when two materials do not have to have physical contact to charge an object. This process requires a conductor, which is the material that allows for the movement of electrons. A temporary example of this is water. When approached by a charged object, water will attract due to polarization. The charges will separate and attract to the rod, regardless of whether it is negative or positive. However, when the charge is removed, it will return to a neutral state. Unlike water, plastic acts as an insulator. In an insulator, the electrons are stationary under normal circumstances. Therefore, in order to charge these objects, we must use friction. By rubbing two insulators together, we are able to obtain a separation of charge. In this example, we have a plastic rod that is rubbed with a piece of wool. What happens is that the plastic has a greater affinity for the electrons than the wool does, creating a movement of electrons that leads to a negative charge on the plastic and a positive charge on the wool. When we do this with two plastic rods, they will repulse, as they both have a negative charge. Since the wool lost electrons, it has a positive charge, so when put next to the negatively charged plastic, we see an attractive force. Here we can see the effective distance on the strength of the interaction. The further away the charged rod moves, the less repulsion there is between the two objects, showing that electrostatic forces are dependent on distance. This can be explained mathematically by this equation, which shows that r, the distance between two charged objects, is inversely proportional to the potential energy. As the distance increases, energy decreases, resulting in a weaker interaction between the rods.